Hi everyone, my name's Adam and this is Greg. We're engineers at Causes and we're going to talk to you about our experience migrating our Rails 2.1 app up to a latest version of Rails. Oh. And we're back. So first off, just a question. How many people are on Rails 3 whatever right now? Awesome, congratulations. How many people are on Rails 2 whatever? How many of you people are planning to upgrade to Rails 3 whatever? Have you actually planned to schedule it to start doing it anytime soon? Good on all of you. So that's where we were at the beginning of this year. And just for a little bit of background about our application in the company. So Causes was a Facebook platform launch partner in 2007. So that was a number of years ago. And we are a platform for collective action, and because we're a Facebook platform launch partner, we quickly grew to around 180 million users, so nothing to sneeze at with that. Because of the rapid growth of the application, we mainly concentrated on scaling for a long time and not keeping up with the latest version of Rails. So we were on Rails 2.1 for a very long time. The size of the code base before we actually did the migration was at around 44,000 commits. From December 2006 up to present, about 1,200 source code files. That was trimmed down from 1,400 source code files, did some cleanup before we started migrating, and just shy of about 100,000 lines of code, and 3,400 lines in the spec suite.
Yeah, so our basic plan was to stop at all the major milestones along the way to the latest state-of-the-art. So we wanted to hit the latest version in the 2.x series as a kind of intermediate stopping point. And then we figured we'd stop on the latest version in the 3.0 series. We weren't really sure whether we would have to stop on 3.1 because we figured that with the introduction of the asset pipeline that might be an interesting point, but in the end we just blew straight past it and went to what was the latest in the 3.2 series at the time. And since then we've kept up along the way. So our basic plan was to begin by getting the spec suite passing. We have about 3,400 RSpec examples in our code base and a handful of Jasmine specs. So we started there at each of those milestones along the way. And then once the spec suite was green, we engaged in a kind of manual QA process where basically we would audit every controller in the application and try to basically exercise every component of functionality along the way. We basically just used the Google spreadsheet to divide that work up among the team and make sure that we hadn't left any holes. And then onto our staging environment, kick the tires with production data or a copy of production data on the staging environment. And then finally, once we'd done that, it was our plan to do a gradual rollout into production, basically one machine at a time until we were sure that it was looking good. And we knew before we even began that we didn't want to have a long-lived branch that existed in parallel to our master branch, because our typical working pattern is to live very close to the master branch, and we try to always have something to merge in at least once a day. And so by necessity, doing a massive Rails upgrade required us to have this parallel upgrade branch. So we knew up front that although there were all these kind of tempting baubles that Rails would dangle in front of us and we'd want to think, oh, look what we can use now, we always had to take the expedient choice and pick the thing that would get us to being able to deploy the new version of Rails sooner rather than later.
So we knew it was going to be a pain in the butt from the get-go, but that it would probably be worth it in the long run. So some of the pain points that we knew we were going to hit were just auditing all of our views because Rails 3 changes the default escaping behavior. So there was nothing magic about that. It was another spreadsheet. Everyone, pick off a chunk of the views and go through and make sure that it's working correctly. Gem compatibility, that's sort of a no-brainer. We knew that would have to happen, but that would be good because we'd get the newer versions of the gems. The asset pipeline, while a fantastic thing, also is sort of hard to roll out incrementally. So we had to devise plans to get around that. Our routes file we had to throw away, which was fantastic because the old routes file was not that good. And a particular problem that we were thinking of was we had this concept of asymmetric routes from when we were more heavily on Facebook and they had apps.facebook.com/causes/whatever. And so there would be a root directory there that would map to a /fb directory on our site. So that caused some complications. One of the things we also did along the way was upgrade our version of Ruby from 1.8.7 to 1.9.3. I think this is just a laundry list of all the things we had to do. It was pretty straightforward. You know, change the Ruby version, see what breaks. You know, kick it as you go. And I'm not going to read all these because they're not super interesting. There were a lot of things that changed, though. This was more of a Facebook issue, but you'll have that. But it was worth it in the end. So if you look at this graph, this is from New Relic, just monitoring average response time. And at about 12:35 is when we pushed Ruby 193. And as you see, it was hovering up around 200 milliseconds, and it dropped to about, you know, somewhere in the 100 to 150 millisecond range. So that alone was a win.
Okay, question about that?
Yeah.
What did you find as it did that? What did memory do?
I didn't work close on that part of it. Lan, anything from the back?
It didn't break.
So another thing that we got to do along the way was upgrade our MySQL gem to the MySQL 2 gem. We were a little scared of this because we had a custom build of MySQL that we thought was really close to Percona, but weren't entirely sure. But as we had been working on the site and working on increasing performance, we realized that if you took the same query and ran it 20 times in a row, one of those queries was going to take on the order of 100 times longer to run. So it would be about 100 milliseconds instead of less than 1 millisecond. We tested in our dev environment that MySQL 2 gem would work better, but we were scared of pushing that into production. This is just more data about the MySQL 2 gem outperforming the MySQL gem. When stable isn't. So with the introduction of the prepared statement cache, are you guys familiar with that in Rails 3? Okay, so we weren't really either. It was in the release notes. We read it at some point. But basically, it's a new feature in Rails 3.1. And it will sort of automatically create prepared statements for your queries. So if you do something like select from users where ID equals 1, it would actually get compiled as a prepared statement with the parameter, the ID bound out, and you can bind in the one parameter. And the advantage to this is executing a prepared statement is a lot quicker than just running a normal query. A prepared statement it'll parse the query, it'll come up with the execution plan, and then once the variable is bound in, it just executes that and returns the result. So it's a great idea in theory. Prepared statements they execute faster, except on MySQL. So this is definitely a speed up for SQLite and Postgres, but not really on MySQL. Once again, we didn't really know this. We didn't know a whole lot about it other than it was a line item that didn't seem to be causing us any problems in our testing. So we launched Rails 3.2.3 on the night of April 18th. And then the next morning, luckily at a reasonable hour, I think we were all in the office at the time, maybe a little earlier than that, we started getting a lot of errors in production about active record statement invalid, MySQL error, can't create more than max prepared statement count. So we're like, okay, that's cool. I didn't know we were using prepared statements. So we did a quick Google and found there was an open Rails issue about this. The statement cache doesn't work for any model with has many relations, which, like our models, were most of them. So it wouldn't be able to bind out two parameters. So you'd end up getting a query that looks like this, and then another prepared statement with group ID is 2, group ID is 3, et cetera, et cetera. Because we launched at night, we didn't have a whole lot of traffic at night, so we weren't getting close to the limit of 16,382 until the next morning. But eventually you do hit that, and we hit that. So the takeaway is when you're moving to the bleeding edge, you might have to pull in commits ahead of what's considered stable. So we found this commit that allowed the statement cache to be disabled. Very simply, prepared statements can be disabled. We put it into our config. We had vendored Rails at that point and pushed into production. Everything worked. So this commit, this fix for the prepared statement being able to be disabled had been 2 months before we experienced this problem, and it hadn't made it into Rails stable yet. So the takeaway from that is, if you're upgrading to the latest version of Rails, be prepared to upgrade ahead of it or possibly roll your own patches to make sure it works in production. I think I'm going to pass it to Greg for this part.
Sure, so we'll move fairly quickly through this stuff. We have a fairly complicated database topology, which involves splitting our tables across different databases on different machines in what we call silos. And we also use master-slave replication. We found that the tool that we'd been using for master-slave replication, masochism in Rails 2.1, evidently wasn't going to work with Rails 2.3. So we started investigating options, things like Octopus, DB-Charmer, the master-slave gem. And ultimately we decided to settle on the master-slave gem because it seems to be a cleaner design. It's basically a shim that sits between active record and the actual MySQL adapter. And depending on the nature of the statement, it decides whether to send it to the write master or the read slave. However, with each update, as we stopped at 2.3 and then 3 and then 3.2, we found that master-slave broke. And so we were constantly having to patch it, and also our own AR extensions code, which is what we used to divide the database models across different silos. So that was a considerable pain point for us. So in the end, ironically, once we got to Rails 3.2, we noticed that there was a bug in the master-slave adapter, which meant that all of our reads were going to the write master. Basically, the first read would go to the read slave, but as soon as you wrote, it would start using the write connection. And funnily enough, performance was still fine. So we actually just decided to rip it out, which was great. So we've kept the slaves, and we basically use them today purely for failover, which is nice. And so I guess the lesson here is that perhaps our database topology was a little too smart. And certainly in terms of maximizing developer velocity, the simpler you can keep things, the better. So just for some examples of what we have a cause memberships table which has nearly 1 billion rows in it. It's not sharded, it's a single table. And we have plenty of date petition tables as well, daily tables, things like that. So yeah, the lesson there is to only silo once you actually hit a performance problem. I'll hand it back to Adam.
So one of the nice things about Rails 3 is you get to use A.ROLL for interacting with the database. As far as caching goes, don't store active record objects in memcache. We know it's bad, we're going to stop doing it. We filed a store in Pivotal Tracker for it. So the basic syntax of using A.ROLL is you can use model.where, and then you can say, whatever parameter, whatever value. And it returns an active record relation. So the thing is, if you cache this, you're caching an active record relation. And when you pull it out of the cache, it's just the relation. It's not the result set. So when you pull it out, it's going to evaluate the query every time. So essentially, your cache becomes a very fancy slight time delay. So it's probably not what you want memcache to do. So if anything, make sure you are casting it to an actual object instead of a relation. But really, you should be storing only primitive types in memcache, and I would encourage you all to do that. Mailers were another pain point during the upgrade. The syntax changed. We had a lot of custom behavior that was implemented via a superclass that just caused a lot of pain points, just tangly, how we hooked it in. And we ended up taking a little more time than we expected to re-implement it in terms of interceptors. The whole thing took a little longer than we anticipated. And that was another, shared spreadsheet, like make sure everyone grabs a chunk and tests it by hand. So the static asset pipeline. Greg, do you want to talk about the silver bullet?
Yeah, so we literally talked about this as the silver bullet. And this is how we sold it to the company in slides. It was a picture of a silver bullet up there on a slide. We basically had this huge untapped potential performance optimization that we hadn't taken advantage of for years, and that is the basic standard best practice of concatenating and minifying your assets. We'd never done that. And here was the asset pipeline waiting for us to do it. However, it's a non-trivial thing. Like, it's not a simple matter of flipping a switch. Obviously, if you put all of your JavaScript into a single file and it's not created such that it can be concatenated, you're going to wind up with all kinds of conflicts. So basically, we knew that we'd have to manually audit every single JavaScript file. So basically, to get us beyond the initial hump and get us rolling, we decided that what we would do is basically symlink our public assets into the app assets directory, and we would minify everything, but we wouldn't concatenate it yet. And then basically, once Rails 3 was out the door, we could start selectively going back as we touched a particular part of the code base and doing things like porting templates to HAML and using Sass instead of normal plain CSS and concatenating our JavaScript. So this unfortunately required huge changes to the deploy process because basically in order to compile these assets, you need to have a number of dependencies available on a build machine, or where you do that. If you don't have a build machine, then you're going to have to make sure those dependencies are available on all of the machines in your data center, which can be considerably difficult. In the end, we went towards the solution of having a shared build machine. So our strategy for the rollout, we knew that one of the trickiest things was going to be managing our async jobs. So we use Beanstalk for async job processing. It has handled literally billions of jobs for us over the years without falling over. It's a great async job queue. But basically what we had to do to roll out was have two separate queues. And initially what we did was have our Rails 2 code start putting async jobs into a separate queue which we called Rails 2. And we waited for the default queue to basically drain until it was completely empty. And then we were able to deploy the Rails 3 code, which would put new jobs into the default queue. And we had workers running Rails 3 consuming from that queue, and then workers running the old code consuming from the Rails 2 queue. And eventually, when we were prepared for all of our machines to roll over onto Rails 3, we were able to let the Rails 2 queue drain, and voila, all of the servers and all of the workers were running the new code. Memcache was another thing that we were worried about having concurrent versions of code hitting. So we were prepared to invalidate the cache, and we bumped a few version numbers on keys, but in the end, surprisingly, it wasn't until the Rails 3.2 upgrade that we actually had to invalidate the entire cache, which was nice.
So the takeaways, we'd advise staying as close to vanilla Rails as you possibly can, instead of hundreds and hundreds of gems in your gem file. Be prepared to pull in commits ahead of Rails stable, like I said, either something that's upstream or something you have to hack yourself just to make the site work. Minimize your external dependencies, once again, staying close to, well, sorry, this one's more of keeping your gem file lean, the other ones don't patch Rails because it's going to cause a lot of pain. Simplicity is a win for the product and for the code base. This was a great exercise for us because not only were we sort of migrating the code base up to the latest and greatest, we were also sort of reinventing what we wanted the product to be. So we were able to simplify the actual product, which helped us simplify the code, which made the upgrade process go a whole lot smoother. So if you're looking at doing a Rails upgrade, if you've had any thoughts about simplifying your product, I would say now's the time to do it. Hack away as much code as you can, get it gone before you start doing the upgrade. And as Greg likes to champion, dumb is the new clever. So if you've come up with a solution that is very elaborate, very intricate, and looks fantastic, try to make it a little stupider. Beware of AREL and lazily evaluated queries.